Here are Adam's heart and great vessels. Anatomically speaking, you can see that they look more like a California freeway system than a box of Valentine's candy. Here are the 4 chambers of his heart: the right atrium, the right ventricle, the left atrium, and the left ventricle. The great vessels that you see include the superior and inferior vena cava, which bring blood from the body to the heart. The pulmonary artery transports blood to his lungs, while the aorta is the body's largest artery. Adam's heart pumps oxygen-rich blood out through his aorta to the rest of his body. Here we've illustrated away some of the tough fibrous coating of the heart and great vessels, so you can get a better look at Adam's heart beating. If you look carefully, you can see a series of one-way valves that keep his blood flowing in one direction. We can label those valves for you. Let's see. That's better. Just from this brief view, you can see that cardiac surgeons really have a lot of very complicated plumbing to think about. They're going to inject some green dye into Adam's superior vena cava, so we can watch it pass through his heart as it goes through the cardiac cycle. Now we can trace the actual path of Adam's blood through his heart. First, his blood enters the right atrium. A contraction of his right atrium then forces blood through his tricuspid valve and into his right ventricle. When his right ventricle contracts, the muscular force pushes blood through the pulmonary semilunar valve into his pulmonary artery. His blood then travels to his lungs, where it receives oxygen. Next, it drains out of the lungs via the pulmonary veins and travels to the left atrium. From the left atrium, the blood is forced through the bicuspid valve into the critically important left ventricle. The left ventricle is the major muscular pump that sends his blood out to his body systems. When the left ventricle contracts, it forces Adam's blood through his aortic semilunar valves and into his aorta. The aorta and its branches carry blood to all the tissues of Adam's body.
My red blood cells are my oxygen carriers. As they travel away from the heart, they traverse smaller and smaller arteries, finally arriving at the collections of microscopic blood vessels known as capillaries. My capillaries contain a high concentration of oxygen and nutrients, while my tissues contain a lower concentration. Through a process called diffusion, these particles leave the capillaries and enter my tissues. Conversely, my body tissues contain high concentrations of carbon dioxide and metabolic waste, while my capillaries contain a lower concentration. In this case, waste products diffuse from my tissues into my capillaries and from there are carried by my venous system back toward the heart. The waste...
So just to kind of summarize what they're saying here, guys, is that this is the blood vessel, this is the capillary, okay? And you can see it's going from red to blue here. It doesn't actually have those different colors. But what's happening as each red blood cell goes by, they're like a truck driver. They're dropping off oxygen and nutrients. Nutrients are in the blood. And they're picking up the carbon dioxide and taking away the waste, represented by the little dots. Put another way, there is a lot of good stuff here and a lot of bad stuff here in the cell. The cell is full of waste. Whether it's, when they say metabolic waste, that's what goes into the toilet, if you will. Okay? That's the stuff the cell has now eaten and it doesn't need any longer, and that will go to where there's less of it. If it's more concentrated here, it'll go into the blood. And if this has something that the cell does not, it'll want to go the other way. That's what this whole business of diffusion is. Stuff it's one of those rules. It'll automatically want to go to where there's less of it. So the carbon dioxide, it's more concentrated here in the cell. It'll want to leave to where it's not so crowded, and it'll join up with the red blood cell that will carry it away.
The waste products are eventually eliminated from the bloodstream through the urinary and respiratory systems. Nutrient exchange is a continuous cycle that is critical for my survival.
So that was a better view than what I showed you on my little illustration of the circle of life. That shows you more what really is happening.
Today's active and animated humans are especially conscious of maintaining a healthy cardiovascular system. While the heart, which is a powerful automatic pump, is the cardiovascular component we think of most often, the blood and the blood vessels are also vital to my health. My blood volume is a critically important 5 to 6 liters of liquid that transports oxygen and essential nutrients to all of the living cells in my body, and also carries waste products to systems that eliminate them.
Most of Adam's blood is made up of a watery, protein-laden fluid called plasma. A little less than half of his blood volume is composed of red and white blood cells and other solid elements called platelets.
Okay, so these are 3 of the main things you saw listed, actually all 4 of the main things you saw listed on your outline. Plasma, what I want you to know about that is it's about half of your blood, and it's basically water. It's a special water with some other chemicals, but it's basically water. That's how you guys can think of it. We can donate plasma. They can take our blood, and even if the person doesn't have the same blood type, they can still use our plasma for anybody. Then the red blood cells, that makes up almost the other half, about 48%, and they carry oxygen and take away carbon dioxide. One of the techniques or strategies for cheating that has been used in the Olympics in the past is something called blood doping. Because the red blood cells carry oxygen, if we have extra red blood cells, we have more of an ability to carry oxygen. So let's say you took out some of your blood and you saved it. And then you kept the red blood cells and you re-injected them later on. Your body's going to constantly keep your level of red blood cells about the same. But if you train in an altitude, like in Denver, your body will make more of them. So a lot of athletes have figured that out. They have the Olympic Training Center in Colorado Springs. That's not by accident. So the higher the elevation, the more of these you make, to a point. But what the cheaters do is they save their red blood cells, and then they re-inject them before an event. If it's, say, something that requires a lot of oxygen, like cycling or swimming, they now have a big advantage. They're not going to get as tired as quickly as someone with the regular 48% if they have extra red blood cells. Pretty sneaky, because these are things you normally have in your body. So it's not like you're taking steroids or something. Andrew?
Do they get caught?
Yep. They didn't get caught for a long time. And what's happening in a lot of athletics is that people are always coming up with new ways to cheat, new chemicals that there aren't tests for. And so then they figure out the test, and then they have to come up with something else. And you know about Landis, the cyclist with the Tour de France. You know, he just got busted, and he claims he didn't do it, but they had some pretty good tests to show that he did do it. Now, the last part here, the 2%, is 2 things. WBCs, white blood cells, and platelets. Platelets are little pieces of white blood cells, little fragments. But the white blood cells, those are the warriors in your bloodstream. They're the thing that fights infection. And you don't always have the same number of white blood cells. If you're fighting an infection, you're going to have more or less? More, a lot more, okay? That's one of the things they look at to see if you have an infection, is they check your blood for the number of those white blood cells. But when you see pus in a wound, or you have a whitehead, a pimple, and you see that white stuff, that pus, that's from the white blood cells fighting an infection, attacking the bacteria. I mean, you've got a great little all-you-can-eat buffet right there on your face. You've got oil, you've got moisture, and you've got food for the bacteria. They just start chowing down, especially if you add a little dirt in there and you don't keep it clean. They'll start chowing down on all that bacteria, on all that food. And the bacteria then reproduce, and you get more and more of an infection. Then along come these guys, the white blood cells. They're your body's warriors, and they'll start attacking that bacteria. And that's why that zit comes to a head, and you get that whitehead. Not a good idea to go in there and pop it as much as you might want to, because now you spread that infection to other pores. Okay? The platelets you'll see in the next clip, they help you seal off a cut, a wound. Those and something called clotting factors keep you from bleeding to death. If it wasn't for platelets and clotting factors, you would get a minor cut and you could bleed to death from it. People that have problems with their platelets or their clotting factors can get a bloody nose, and they could bleed to death if they don't do something to stop the bleeding, because their body just keeps letting it out and it doesn't seal it off like yours and mine will.
A little less than half of his blood volume is composed of red and white blood cells and other solid elements called platelets.
Last one.
Ouch! Oh, maybe I should have stuck with whole wheat toast. Each of my fingers has numerous small blood arteries that were waiting for the knife to attack. Today, I've selected my thumb. Here's a cut section of a small artery. The traffic going by includes red blood cells carrying oxygen, platelets, which come from white blood cell fragments, and clotting factors, which are the little yellow guys that help my blood to clot. The cut from the knife broke my intact skin, and you can see the blood cells and fluid oozing out.
Adam.
The cut also exposes the collagen fibers in my tissue, which begins the clotting process. As platelets begin to adhere to the cut edges, they release chemicals to attract even more platelets.
So imagine now someone's broken into a store. They threw a rock through the glass. First thing you do is go out there and you put the board over the front. You make a temporary repair. And that's what's happening here with the platelet plug.
As platelets begin to adhere to the cut edges, they release chemicals to attract even more platelets. Eventually, a platelet plug is formed, and the external bleeding stops. Inside, the clotting factors take a much more active role by creating a cascade of clotting activity. The clotting factors cause strands of blood-borne material, called fibrin, to stick together and seal the inside of the wound.
So this would then be the permanent fix that we're making with fibrin.
The clotting factors cause strands of blood-borne material, called fibrin, to stick together and seal the inside of the wound. Eventually, the cut blood vessel heals, and the blood clot dissolves after several days. Toast, anyone?